Alright, in this video we're going to do some practice with balancing nuclear reactions. This first one I have beryllium-9 plus, and this we would say is helium-4, but really this is an alpha particle, 2 protons and 2 neutrons, is going to make carbon-12 and something unknown. Well, it's important to note that whatever I have for mass here, I need to have at the end. Same thing for down here. So I know that 9 and 4 is going to add together to be 13, so on the other side I have to have that as well. So I need to account for something over there that's going to be at least a mass of 1. Then I know that I have 4 protons here, 2 protons there, so 6 there, so I don't need to do anything to take care of that. I'm going to put 0, and here I have a mass of 1, but 0 protons, a charge of 0 as well. That's going to be a neutron, so that's going to be my missing part for this nuclear reaction. That would make it a neutron. So next up, I have polonium-212 is going to break down to form an alpha particle, and the remainder of it, that's what we're going to solve for. So I have 212 here, and this needs to be the same over there, so that's going to be 208. So 208 plus 4 gives me 212. And I have 84 protons here, 2 over there, so I need to count for that. So I'm going to have 82 protons over there. 82 means that that's my identity of lead, so I'm going to put that there. So that is going to be lead 208 is going to be what I solved for right there. So, in the decay of polonium, alpha decay means it's going to release an alpha particle plus lead 208. Here I have Einsteinium plus an alpha particle is going to release a neutron plus something unknown. So I have 253 and 4 there. And so it's going to break down and release a neutron. So I know that that total on the left is going to be 257. So on the right it needs to be the same. But here it's going to be 256 because I already lost one with the neutron there. I have 99 protons plus 2 means I have 101 on the left. On the right I don't have anything that's going to affect that at all. So that's going to be 101. So 101 is going to put it as MD Mendelevium. So when Einsteinium gets hit with an alpha particle, it's going to release a neutron and Mendelevium 256. Next up, promethium plus something is going to break down to make neodymium. So neodymium 142. So I need to figure out what's the difference there. Well, I have 142 on the left and 142 on the right, so the mass is going to remain the same. But the proton number has changed. It's gone from 61 to 60, so it's actually decreased by 1. Well, the only thing that can do that is a -1 down there. That's going to represent an electron. So we had electron capture right here, where one of the protons got turned into a neutron. So the mass didn't change, but the number of protons did, so that's why it's changed identity into something else. So that's an electron. Beryllium-9 plus an alpha particle, helium-4, is going to make something plus a neutron spit out from there. So I know I have 9 and 4, so that's going to be 13 right here. To account for that difference, I'm going to put 12. I have 4 plus 2 on the left and 0 over here, so that's going to be 6 right there. I know that's going to be carbon, so that is going to be carbon-12 plus a neutron is released. Here I have sodium-22 plus something is going to make neon-22. So you'll notice that the mass number has not changed, but the protons have. So I know it's going to remain 0, and I go from 11 down to 10. So we know that that's going to be a -1. So this is another case of electron capture, where a proton is going to get turned into a neutron by absorbing an electron. That's going to be my unknown.